everyone, I'm back with very interesting topic today, that is about access control list. We will try to learn what kind of access lists are there, why you need it, what kind of parameters you can match in that one, and what kind of different access lists are there. For example, standard, extended, or named access list. At the end, we will be having the quick labs for all these different types of access control list. Those who don't know me, my name is Vikas and I will be covering CCNA, NP and IE. Please hit like and subscribe and hit the bell icon so you can be notified for the upcoming videos. Let's get started. The first thing we will try to understand is why you need an access control list and what kind of parameters you can match in that one. For example, you will be using routers, switches, firewalls, even on the wireless LAN controllers, you will be using the access control list. It serves different kind of purposes. For example, you can filter the packets which are not intended for your network. You can use it in the route maps for matching the different routing tables and their routes. And you can also use it for filtering specific ports, specific destination, source, and even you can use it in the QoS. And we will be also trying to use it in the management traffics, for example, SSH, Telnet, and VPNs. We will try to use in that kind of environments as well. Even we can control what kind of traffic will hit to the CPU for further processing. We can go till that in-depth level of access control list. But the main purpose of ACL is to filter the packet. For example, you have a source and destination. For in our example, we have 10.1.1.1 on the left and we have 20.1.1.1 on the other side. In this example, what are the places you can deploy the access control list? The best approach to deploy the access control list is as closest to the source. That is the best place. The reason is very simple. You can save a lot of bandwidth and you will have better control over that traffic. You know where this traffic is going to exit and where it's going to be the destination. In our example, what are the places we can deploy the access control list is on the inbound interface of router 1, which is fast Ethernet 0/0, or you can also place the access control list in the outbound direction on the fast Ethernet 0/1. If you don't want to have the control, or maybe this is your source and you don't have control over that, you can also control it on the destination side of it in inbound direction on fast Ethernet 0/1 on router R2, or you can also control it in the outbound direction of fast Ethernet 0/0. So you have 4 places before this traffic reaches to the destination. You can place it on R1 or R2. You will always look into what is the flow of that traffic, and based on that one you will place the access control list on that one. If you notice on the packet level, what kind of interesting parameters are there to match in the access control list? You can match the source, you can match the destination, you can match the source port numbers, you can match the destination port numbers, and you can even match the protocols. But when it comes to the IPS controls or next generation firewalls, they have further controls over that traffic. For example, when it comes to IPS specifically, you can even match the fragments. You can match their sequence number. You can do a lot more stuff with the access control list. You can have a lot of granular controls over their traffic. Let's quickly do one example. I want to block the traffic for ICMP from source to destination. What will be the places I can deploy? As we highlighted, inbound, outbound direction, you can deploy the access control list. You just need to mention from where the traffic is going to come, what will be the direction of that traffic, and based on that one you will just place that access control list. In our example, let's create one access control list. What is this access control list does is, think it in a way it is if then. This is the only method to deploy the access control list. You will be having a loop in that one. For example, if source is 10.1.1.1, destination 20.1.1.1, what will be the action? Then you will do it allow or deny. That's simple, I guess. You will just do it if then analysis. Based on that one you will create the access control list. Can you do the complete network block? Absolutely, you can do it. You can add the mask in that one. You can do the access control list based on the host as well. There is no issues. The only thing matters in the access control list is what will be the if statement and what will be the action for that one. And these actions are going to get executed based on their sequence number. For example, if your sequence number 1 says allow the traffic and you have a sequence number 2 which says deny that traffic, the traffic will be executed already, so the deny statement will not be applicable. In the other example, if the deny statement is first, let's say deny any, and you are allowing any certain traffic, it's not gonna work. You need to always allow the traffic first, then deny that traffic. Or you can do the other way as well. For example, you deny the specific traffic and allow everything. Both ways are okay. It's just based on your requirement, you will be doing this configuration. Now let's try to understand what kind of different access control lists are. For example, we have standard, extended, and named access control list. In standard, what happens is we identify based on their number. For example, access control list 1 till 99, you have standard access control list. Then in the recent versions, they have introduced starting from 1300 till 1999. This is also referred as standard access control list. And if you will be using any number from this range specifically, this will be considered as standard access control list. And you have very limited control in the standard access control list. You can only control what will be the source. You cannot control the destination. It does not matches the header information of destination in the access control list. You can block the source host. You can block the complete network. These are the two controls you can do, host or the network. This is what standard access control lists are. What is extended control list is, in the extended control list, we have numbers starting from 100 till 199, you have extended control list. And you also have an extended range which starts from 2000 till 2699. This is the extended version of extended control list. If you will be using any of these numbers, this will be referred as extended control list. In this one, you have more granular control over that traffic. For example, you can mention the source, you can mention the destination, you can mention the destination port numbers, even you can mention the source port numbers. You can match all this information from that header which I shown you just now, and you can control that traffic. And you can allow that, or you can deny that, or you can do further action on that traffic. The last one is named ACL. Named ACL is technically not a separate category. What happens in this one, it does not have anything extra than the standard or extended. In this one, the only part happens is it creates the named base access control list. In the previous one, you have seen you are mentioning what will be the number of that access control list, 1 till 199, 200, 300, whatever. But in this one, what you will be mentioning is access control list name, for example, IP shuttle. And you will be also mentioning, is it going to be standard or extended access control list? Based on this one, you will be creating the controls. In terms of controls, that stays as it is. If you will be mentioning standard, it will be considered as standard access control list. You can only match the source. If it will be extended, you have further controls over that traffic. Source, destination, port numbers, and other kind of controls. Hope it clarifies the information, what is the different types of access control list. Let's do one example for standard access control list. In standard access control list, we know we can only match source. In our example, we are going to allow the communication only from 10.1.1.1 and we want it based on the host. In this one, what are the places we can deploy the access control list? As we have already discussed, it will be in the flow of traffic. We can deploy this access control list in the inbound direction, outbound direction. That's up to us. Let's make that access control list. In standard access control list, what will be the format of that one? Access list, let's take a number 10. This is going to be a number which we highlighted. The access control list is going to be from 1 till 99. or from their extended range. Any of the number you can utilize here. Based on this one, your iOS is going to identify what kind of access control list is this. Next, you will be mentioning what will be the action on that one. You want to permit or you want to deny. Then you will be just mentioning what will be the IP address, 10.1.1.1, and that's it. Or you can also do based on host, and you can mention host 10.1.1.1. Now let's try to execute the second part of our statement, deny whole network. We have already permitted 10.1.1.1, that is based on the host. Now we want to deny the remaining subnet. How we can do it? Very simple. The same way, we will be adding another statement into the same access control list number, and it will get executed in sequence. The first statement is going to get executed. After that one, it will be going to the second statement and execute that. The first statement says we have already permitted 10.1.1.1. The second statement we will be doing is access list 10, our action, permit or deny. We will have the whole network 10.1.1.0. I have made it /24. And the last part here, we will not be mentioning subnet mask. Here we will be mentioning wildcard mask. If you are not aware what is wildcard mask, the link is above. You can go check it out, how to calculate the wildcard mask. And you can also learn what is subnet mask, network IDs and everything. But here I have just added a second method of calculating the wildcard mask. If you have already seen that lecture, that was for very initial level. Let's do something extra here. Let's calculate one wildcard mask here. How you can do that? For example, our network ID is 10.1.1.1.0/24 and our subnet mask is 255.255.255.0. How we did that? Check the lecture. Here we are just going to highlight how to calculate the wildcard mask. You will be placing all 4 octet as 1 and you will get the values for 255.255.255.255, and you will minus it the subnet mask from this one. Let's minus it 255.255.255.0 and you will be getting your wildcard mask. It's that simple to calculate the wildcard mask. In the previous lecture it was little longer, but I wanted to take you through all the different methods and make your base based on this one. If you have practiced that, this is you are going to understand in a second. And this wildcard mask, we will be placing it in the access control list. And our complete access control list is ready. We can now just apply it on inbound direction or outbound. Let's do it. Access group 10. This is the access control list number. And we are just mentioning inbound direction. That's it. Let's do the second example we have for extended control list. In this example, what we have is the source to destination. We will be creating an access control list based on further information. I want to control it based on the destination as well. Let's do it. Access control list 110, that is the extended range. Our action, permit or deny. And I want to match host 10.1.1.1. What will be my destination? 20.1.1.1. So you will mention this one in your access control list itself, and your access control list is ready. In this one, you have already mentioned the source and you have mentioned the destination. You have more granular control over the traffic. And if I want to do this one based on the network ID, how we will be doing it? We already calculated the wildcard mask. Let's quickly do this example as well. Access control list 10, permit or deny, and our source host 10.1.1.1. The destination, I want to make it based on the network. Let's make it 20.1.1.0. Since it's /24, the wildcard mask is going to be 0.0.0.255. You have matched the whole subnet, and this is going to be your destination. That's how we apply the access control list in extended mode. There is another variant. In this one, you can also match the port number. If you have the destination port number, let's say for ICMP, or you want to match it based on specific port number, let's say Telnet or SSH or HTTP, you will just mention EQ and you will be mentioning what will be your port number. In this one, if we read the syntax of the access control list, it's little different. In this one, we are mentioning the protocol as well, and in the protocol we will try to match what is the exact protocol. For example, HTTP is a TCP protocol. We highlighted what will be our protocol, TCP, and what will be our destination, port number 80. That's what in extended control list we do. The last type of access control list we have is the named. In the named one, we have the same capabilities, standard or extended. There is no difference going to be. Only thing is the syntax is little different than standard and extended. Let's quickly do one example and you will understand easily what is the difference. For example, in the same way we have did the source 10.1.1 to allow the communication till the destination. Let's make it in the standard mode. You will be configuring IP access list. You will mention standard or extended here, and the last part is the name of that one. After this one, you just mention what you are trying to do the action. If you will mention the standard, you have the source. You will just mention permit host 10.1.1.1, or if it is based on network, you will just add the wildcard mask at the end and it should match the whole subnet ID. In extended mode, that syntax is also same. You just have to create the access list based on the name extended, IP access list extended, what will be the name, and then you will be making that same format of extended control list. For example, permit, here we are mentioning the protocol, TCP, IP, UDP, ICMP, anything you can mention. If you do the question mark, you find out all the different ports and everything. You will be matching what will be the source based on the host or based on the complete subnet ID or network ID. And the last part is going to be the destination, and you can match the port number as well. That is the way how you configure the named access control list in standard mode and extended mode. The capability wise, we have already discussed, it is same. There is no difference in that one. Hope you got the idea of all three different types of access control list. Let's head towards our labs, how we can quickly run one exercise from each access control list type, and it should clarify all the questions. Still, if you have the questions, you can reach me on the Facebook or on my YouTube channel. So this is going to be our lab. In this one, we have the same exercise we was doing it in the example. We will just try to implement and see what kind of commands you can run and how you can verify different kind of controls. In our example, on the source side, we have two different hosts, 10.1.1.1 and we have 10.1.1.2. We will be allowing the communication from one host and deny the communication from any other host. And on the destination side, we have two different servers. We will be able to verify how we can reach that communication. In this one, we are practicing the standard access control list. We will not have the control over the ports or traffic or destination. We will just match the source and apply this one on the interface. Let's quickly configure one access control list and allow 10.1.1.1 to go out. If we go back onto the router 1, here we will be configuring the access control list. Let's go to the CLI and we have all the routing protocols and everything configured already, so everything is fine. Let's do show IP route and we have all the routing and everything running fine. Let's configure the access control list quickly. In this one, we are configuring a standard access list. So it's very simple. You will just mention access control list 10 permit. This is going to be the action. You have, if you do the question mark, you have permit or deny. These are the two actions. You can also add the remark. What is remark is, it's just a descriptive name for this whole access control list, what it's gonna do, or you can add any kind of description on that one. It's good practice to add it, but it's not a mandatory part of the access control list. I do recommend always add it so that tomorrow someone comes in your network, he knows why is there. All right. So we want to add, let's say I want to add the remark, allow communication from R1 to allow communication from 10.1.1.1. So this is how we add the remarks. Let's do the second statement, permit. We want to allow the host 10.1.1.1. All right. And let's quickly check what is the access control list configured. If you notice here, we have standard access list number 10, and it has one statement which says permit host 10.1.1.1. Where is the remark for this one? Okay, so let's do the show run and let's go to the command section, and you will notice the access control list section around the end. Let's go there. If you notice here, the access control list 10 have a remark on that one. It says allow communication from 10.1.1, which we added. It seems perfectly fine. Now we just have to apply this one in the inbound direction so that we can control this traffic. Let's go to our interface, quickly check what is the interfaces we have. We have Gig Ethernet 0/0, that is the inbound direction for our source. Let's apply it on this one, Gig Ethernet 0/0/0. Before this one, if we try to ping it from source 10.1.1 to the destination, we should be able to do all the communication. Let's try it. That's a good way to test everything is working or not working before our practice. If we go to the desktop of this PC and let's go to CLI, let's try to ping it 10.1.1.254. This is our gateway. It's pinging fine. Let's ping 20.1.1.1. That's interesting. We are not able to ping it. That's great. Oh no, we are pinging. So it's fine. Actually, it was just resolving the ARP. The first packet gets missed sometime. That's okay. It's a simulator. Even in the real life also, we see this kind of issues. IT never works in first time. So it's okay. Alright, so we are able to reach the destination. We will be noticing from 10.1.1.2 the communication is not going to work after applying the access control list. Let's quickly do a ping from that as well, that we are currently able to reach 10. Ping dot. In this one also, let's do it. Ping 20.1.1.1. Yes, we are able to reach. Let's go back to the router. Alright, let's go to the interface, Gig Ethernet 0/0/0, and we will be mentioning IP access group. Here, if you notice, we have the name or number. That is where we mention named access control list or the normal one. So let's mention our number. We have access control list number 10, and it will ask you want it in the inbound direction or outbound direction. If you notice, the traffic flow is going to be in the inward direction. The initiation is happening from the 10.1.1.1. We want it to go inside the router, so it's going to be in the inbound direction. So let's make it in, and let's go back to 10.1.1.2 and let's try to ping it from there. What's going to happen? That's interesting because we didn't added any communication. So what is happening is the router is started denying the packets actively, and we see the destination host unreachable. But if you go to the 10.1.1.1 and you try to ping it from there, all right, you are still able to reach the destination. So this is how you apply the standard access control. What kind of show commands you can utilize? If you go back to the router, let's quickly do some checks that how you can verify your access control list from the router side, how it is working. Show access list. So if you notice here, it says after the access control list, it says 4 match happened. That means our access control list is working. All right, so here we can also do the named access control list as well. There is no difference. We can convert the same example into our named access control list. In this one, we can make another variation. For example, rather than allowing the communication from 10.1.1.1, we will allow the communication from 10.1.1.2. So that's gonna be our source. Let's quickly do that configuration as well. Let's go to the router. In this one, we will create the access control list, IP access list. In this one, if you notice, we have a different syntax. Here we are mentioning standard or extended. You just select the standard and you can give the name or number as well. This is gonna be a simple name, any description name you can keep it. Let's keep IP shuttle. I want it to be the name. Let's do what kind of things we can do. In this one, you can permit, deny, you can add the remarks, anything what you was able to do in the normal access control list, you are able to do it here. Let's add the remark same way. Allow communication from 10.1.1.2. Let's do it from this side. And you will just mention permit host 10.1.1.2. And we have our access control list. If you do show access list, you should be able to see the same format. Just do show running and we should be able to see the whole access control list with their remarks. Let's go to the end of that one. If you notice here, the format is just a little different. It's have remark, it has the name for that access control list, and let's apply it on the interface the same way. Interface Giga Ethernet 0/0/0. All right, and IP access group, it's asking for name or number. We are just going to assign the name IP shuttle. We will be highlighting in or out. We want it in the in direction. That's it. The access control list is applied. Let's go back to the device. All right, and 10.1.1.2, we are on that. We have the communication up. And if we go to the host 10.1.1.1, this host was able to ping earlier. Let's try to ping it from here. We should not be able to ping it. And we see it's working fine and it's saying destination host reachable. The other host is still able to ping it. Let's do the second example for extended ACL and named extended ACL. In this one, we will try to match the destination IP address as well as we will try to match the destination port numbers also. For example, we have 10.1.1.1. We want the web server to be accessible, which is running on 20.1.1.100. We will try to browse it from the source and we will try to block that one. In this communication, we have to match the protocol, the destination, its port number, and we'll see how it works. Let's quickly do both of the example. In this example, how about we change the direction of that traffic and we try to apply it in the outbound interface of R2. You will have the feeling of both types of in and out. What is the difference? Let's quickly do a configuration on R2. We just need to follow two simple steps. One is if then statement, and the second one we have to apply it on the interface in outbound direction. Let's go to the PC2 and we will try to browse the destination web server and see if it is working before we apply the access control list. Let's go to the browser and let's try to browse HTTPS or HTTP, whichever you like. And let's try to do 20.1.1.20.1.1.100 and we have the web server working. Let's now try to match it in the access control list and we will try to allow it from the 10.1.1.1 and we will try to block it for 10.1.1.2. It should not be able to browse it. Let's go back to the R2 router and let's go to the CLI. Let's configure the extended access control list. How we do it? Access list, the number. If you notice, we have two different ranges. Let's configure it 110. Action, permit. We want it for protocol specific to TCP. This traffic is part of that TCP traffic. So let's make it TCP traffic and we want the host 10.1.1.1. We want this host to browse the destination host and the destination will be 20.1.1.100. That's our web server. And we want to match what will be the port number. Here we can also type the name as well. Sometimes it's perfectly fine. For example, if you mention port number 80, it will also take it as www, that's the web browser. Or you can mention the port number for HTTPS. Since we are testing it for HTTPS, let's make it. It's gonna be 443 port number, and we can just check our access list, show access list, and we have our extended access list. It completely mentions extended IP access list number. Let's go to the configure terminal, and we want to apply it in the outbound direction to do show IP interface brief. What do command does is we are just executing the enable mode commands in the privilege mode, and let's apply it on the interface of 0/0/0 in the outbound direction. Interface Giga Ethernet 0/0/0 IP access group. I want to apply 110 in the outbound direction. All right, so the access control list is applied. Let's go back to 10.1.1.2. It should not be able to browse the web server now. Let's go to the desktop for this one, and let's go to the browser, and let's try to browse it. HTTPS 20.1.1.100, and if you notice, we are not getting any page on this one, so that's mean we are not able to reach it, and we have the request timeout. So our access control list is working fine. And if we go back to the same PC1, and if we try to refresh that one, we keep getting the page. Even we can browse the next pages as well, and it's working fine. This is how we apply the access control list in extended mode. Now let's do this one in extended mode as well. It will be named extended ACL. Let's go to R2, and let's configure IP access list, and you will be selecting standard or extended. We want it in the extended mode, and let's name it IP shuttle. Let's quickly do it. Permit, we want it under TCP. Our host is going to be 10.1.1.2 and the destination host 20.1.1.100 and EQ. All right, it's gonna be 443. That's the HTTPS port. Let's apply it on the interface Giga Ethernet 0/0/0 in the outbound direction. IP access group, we want it name IP shuttle, and in the outbound direction. Let's go back to the PC1, which is 10.1.1.2. It was not able to browse earlier. It was request timeout. Let's try again, and it's able to browse it. We can see the images on that website, and seems fine. All right, let's go back to the other one, 10.1.1.1, which was able to browse earlier, and we should not see any website on that one. It should say timeout because we have rejected the traffic. And let's refresh it. It's loading and seems working. It says request timeout. That's how to apply extended control list in normal mode and named mode. Both are same capabilities and everything. It's always good practice to add the deny any command or deny any command at the end, just to avoid maybe unintended traffic to move through the access control list. You don't want that. You can always add it. Just add another statement and it will start getting executed. That's how we apply standard, extended, and named access control list. Hope you got the idea how to work with access control list. You will be always using it in different devices, different iOS. You will always need that. If I have increased your knowledge in any ways, please hit like and subscribe and hit the bell icon so you can be notified for the upcoming videos. I will see you in the next lecture. Take care.